Good morning, good evening to everybody all over the world. I'm Jose Macharé, chair of the Committee on the Disaster Risk Management of the World Federation of Engineering Organizations. Despite huge efforts during the last 30 years, we still can see that disasters continue occurring. Every year, there are huge damage and loss. The economic losses is counting tens of billions of dollars. There are tens of thousands of lives lost every year. We also should remember the permanent disabled and homeless and displaced people, and also the damage on the built environment. Built environment, infrastructure is damaged and destroyed every year. Finally, the natural environment also suffers. Natural and cultural heritage are strongly affected. As a result, the development of the societies is hampered. So our federation and our Committee on Disaster Risk Management is focused on help and contribute to the achievement of the Sustainable Development Goals. In our case, the main SDG is the number 11 on sustainable cities and communities. Briefly, to tell you that the Committee on Disaster Risk Management is composed by 30 members of the 5 continents and grouped in 5 working groups. We developed along the year a program with webinars and discussion panels as this of today, also short courses and publications. For today, we have a very important subject and will be treated by Dr. Kit Miyamoto, a world expert on this. And also we will have a discussion panel with a couple of highlight specialists in the matter to present this and to live in the conduction of the meeting. Sorry, I will have to say that this webinar of today is organized specifically by the one working group, is the working group on capacity building of the CDRM. For the conduction of the meeting, I told you I'm going to leave to Dr. Viviana Iris Novelli. She is member of our committee. She's a structural engineer with a Doctor of Philosophy in Earthquake Engineering, awarded by the University College of London. She is a lecturer in civil engineering at the Cardiff University now, and a disaster specialist leading international projects that focus on earthquake modeling to assess the building performance. And also in pre and post earthquake assessment, she has worked in Europe, Middle East, Africa, and South America, sorry. Her work focuses in developing pathways to mitigate the disaster risk driven by climate change, mainly through resilient and sustainable engineering strategies. She has also had a significant involvement in these topics via her AECOM industrial experience. She provides structural consultation to the World Bank, and she is also part of the management committee of EEFIT. And as I told you, a member of our committee on disaster risk management in the capacity building team. So I give the floor to Viviana Novelli, please.
Hi, thank you very much, and good morning, good afternoon to everybody. It's really a great pleasure for me to be here today and moderate this session with a very respected expert in disaster risk reduction and disaster response and reconstruction, Dr. Kit Miyamoto. But before I introduce our speaker, I just would like to say a few words on today's topic. As a magnitude of natural hazard and climate change disaster and political conflict increases, significant humanitarian crises are progressively more prevalent around the world. Terrible events like these impact lives of billions of people and continue to bring up engineering challenges. Humanitarian crises present the opportunities for taking significant actions to enhance built environment resilience, reduce damage and facilitate recovery, save life, and restore communities. Actions must be delivered with timely results and must be easy to use and adapt to existing structures and communities affected by wars and military aggression, which could have violated their basic human rights and could have caused long-term consequences in their development. Therefore, it is essential that engineers understand not only how recovery strategy may be used for good, but also how they may contribute to the sustainable development of a community. The speaker in this section, this section today addresses the role of engineering in conflict environments in need of humanitarian assistance and disaster relief. Our speaker, Dr. Kit Miyamoto, is a global CEO of Miyamoto International, worldwide engineering and disaster management firm, which counts 25 offices in 4 different countries. With one purpose, make the world a better and safer place. Dr. Miyamoto led numerous disaster response and recovery efforts worldwide in the past 20 years. He provides expert engineering and policy advice for USAID, World Bank, UN agencies, and various governments. He holds a graduate degree from the Tokyo Institute of Technology and California State University, where he has been recognized as a distinguished alumni. He has won the Engineering New Records Global Best Project Award and presented 3 consecutive times. Major media such as ABC, CNN, LA Times, New York Times, and Rolling Stone have profiled him. Today, Dr. Miyamoto will discuss his recent experience in current activities in Afghanistan and Ukraine. The title of his presentation is Engineering for Humanity, Cases in Afghanistan and Ukraine. To all participants, please be advised that this event will be video recorded. Thank you.
How's that? Can you see well?
It's okay.
Yes, perfect.
All right. Well, thank you so much. And good afternoon, good evening, good morning, everyone. So I will spend the next 40 minutes to go through these 2 different types of disaster. And one is caused by the earthquake, and one is caused by obviously human. But there's definitely common parameters between this type of different disasters and how the engineers can really assist for fast and lasting recovery. So that's that main topic here. So just a little bit our company, we are located, as you can see, throughout the 5 different continents now, and from all the way from Turkey to down to the Colombia. And in Latin America and the Caribbean countries, we have a presence in Mexico, in Colombia, in Costa Rica, and Puerto Rico and Haiti, place like that. And mainly located in essentially the highly exposed to both earthquake and a hurricane and a flood area. That's where we are. Just to you to know, the half of our engineering business is a normal engineering. We do structural, mechanical, electrical, plumbing engineering, or just building systems. And half of it essentially what we call international development and humanitarian assistance, which is essentially we work for the USAID and World Bank and UN agencies to actively response to the major disasters, or they're preparing for the disaster to happen. So this is the Afghanistan. So there was an earthquake, and this is actually this year, June, and it exposed about 80,000 to 100,000 people in a homeless state. Earthquake itself was not particularly large, around magnitude 6 or so, but it was a fairly shallow earthquake, and it got a fairly high intensity in a vicinity of this. And this area is located in essentially if you know Afghanistan, it would be Pakistan border to the east side. That's where that is it's very difficult to get to. Takes about 6 hours, maybe no, it takes actually all day long to driving from Kabul to the area. And even the flight down takes a day to get there. So it's very difficult to get to. And obviously political security environment is not great there, as you know. Taliban is essentially what we call the de facto authority, and we need to collaborate with them to actually work with the local people, to make sure things get set up. So this is a collaboration with the IOM. That's one of the UN agencies who specialize in the internal displaced people and how to deal with it. So this particular case, the UN agency conducted a very broad scale assessment just throughout the whole area for several thousands of structures. And but it was not having the technical data set. So as engineers, we need some technical understanding of what happened to the damage index of each of the houses or buildings, and understand what is the repair methodology and the potential cost will be. So since we got there fairly late, around the end of July, so we did the random sampling analysis, this case about 550 different, what we call compounds, which we showed you, just a cluster of housings essentially, and affecting about 2,700 families. So using the statistical kind of approach, that's what we done here. So we use the ArcGIS platform and Survey 123, we program into it and to train I think this case around 30 local engineers, and go out in the field and they collect the very specific structural data, what's made of, what type of building system is, what the damage patterns look like, and that's pre-programmed those things, and what is the way to fix it, what's the potential cost of fixing it. So once you collect the data, you put it into the ArcGIS format like this, so you can see that yellow, red, green type of distribution. Red is heavily damaged compound, yellow is the medium, green has nothing. So you can see the patterns of it. So that's how we look at and use the remote satellite image to understand the overall scope of damage, just doing a sampling technique. And we collect usually this depends on, but you definitely want to collect the minimum 2% of a total distribution. But this particular case, we went up to about 5 to 10%. So we have a fairly decent confidence about what happened to the whole affected area. So based on this, we see the so-called red tag, which means collapse or heavily damaged, about 17% of a total asset in the area. And 51% is a yellow, which means that it's damaged but repairable. And habitable means there's no damage, immediate damage you can repair, you can use that facility. It's about 32%. So interesting, this fact is first, it was a pretty big disaster in the area because the last earthquake they saw was almost 120 some years ago. So it's an earthquake prone area, but the residents, the local people really didn't know that's an earthquake, area per se, right? So everybody got to really panic. And it's just a lot of buildings collapsed. But the bright side, if you look at this data here, 50% damaged, 50% total stock of this, so-called damaged buildings or houses can be repaired fairly rapidly. We estimate about 4 weeks or less to repair those damaged houses. So which means if you focus on this so-called low-hanging fruits, right, this yellow tagged houses, 80% of a total building stock can be occupable, which can be done before this winter season, which is happening right now as we speak. So speed is a key. And interesting part of it is the, it's really critical part of it to try to use the locally available materials, respect the local architecture and the local available labor, and try to have money stay much as possible in a local area, affected area. That's actually extremely critical to have the this disaster to be lessen, burden to people. So those are the main things we looked at. So let me describe what compound looked like. You see, it's an absolutely beautiful area. I mean, this is a area where people like us has no access to it because it's very, difficult, terrain, and also the politically unbelievably stable. This is the area where Taliban was actually coming from, So it's been a war for the last 40 some years. So that's people tell me about it, 40-year war. So here's a compound structure look like. It's essentially that they look like a large castle almost. And average about 6 to 7 families live there. It's not in the same basic clan per se, and made of clay, because that's the material available locally. Clay, that's what they use, clay and wood. And it's a very interesting structural system, I must say. So compound wall, it's what we call partial wall. It's essentially it's a clay locally harvested it, and where it's built, pounded in to make a very stiff structure. So this wall, you're talking about 5 meters high. It's a gigantic structure. And interesting part of it, we didn't see the many collapse of this kind of wall. And estimated ground accelerations is somewhere around 0.3 to 0.5 G hitting certain area. And you don't see much damage in it. It's not amazing. That is there's no reinforcement. There's none of that. It's just the way it's built, it works. And also there is the so-called clay brick, structure like that. Usually the smaller buildings use a clay brick. It's I think again locally harvested, dried clay, and it just build up like that. So why this construction works? Essentially clay, and if you compare it against the cement, concrete, a lot of similar kind of things going on. There is the gravel, and there's stone, sands components there, and cement and the clays essentially provide the cohesiveness between these aggregates per se. So if the clay and a combination of water and an aggregate, that's caused the very homogeneous, essentially, the components of it. It's not a hugely difference from how this, concrete is actually made of, if you think about it. But there's very important components of what type of clay exists. So we actually brought in this experts from France who actually conducting this clay, construction for so long time. He basically tested using the different approach. It's a hydrating soil. to see how plastic is. It's how to see how cohesion of the test is. So what he does is he makes this long piece and how actually stable the pieces. This case, he found about this cohesion that's almost 20 centimeters without no failures. And he was very amazed. He just, I can see why people built such a huge structure from this area, because this is probably one of the best clay he's seen in the global scale as far as the building material is concerned. And how the grains composition of look like. And he liked that because it's a very sharp edge components of it. That's something you can bind better. So system is essentially something like this. It's a rocking structure. It's what you see in a cut section of this, that there's partial wall, this large compound wall, and inside of it, there's a little rooms built around it. And there's a wood joist and a connecting these two elements. This is extremely flexible structure, by the way, very flexible. And it's a dynamics is essentially the rocking system. It's not much different from the minarets in mosques. Essentially, it's rocks. And it's not only rocks in one unity, it's actually made of the chunks of this clay layers. So it's actually, there's a lot of interaction going back and forth. So it's a very stable structure. So even simplified analysis, we see that it can take up to 0.5 G, but they're probably much higher because of the actual that compartments itself has to interact with each other. So how to actually each system look like? What is the critical components of it? We see the critical components, the bottom piece of it, which is made of rocks. That's actually very important because clay, if exposed to the water, it melts. So you cannot expose the water. So having the rock foundation is a very important part of it, as you can see right here. And also how the earth wall is made of and also coverage of it. And in many cases, they build the clay, and after that, have the mixture of the plaster, which is usually composed of the clay and also the just hay, stuff like that. So make the essentially water to drain faster. You can see how tall the wall is. Pretty amazing, isn't it? Those are usually 5 meters high. Capping is an important one. Also, that's how not to have the water to go into the inside of a wall. That's actually critical. Just protecting from a wall as much as possible. And soil coverage over the roof, that's important. But one of the most critical failure modes we saw here is over the years, people built this clay on top of each other to essentially do for the heating per se. It's a really cold area. It's almost reaching about 3,000 meters or so. So it's really cold in winter. But problem over the ones that laying over it, some cases you see the thick as 2 meters. I'm talking about heavy roof, and also some cases you see the joist structure. This particular case, a pretty good practice showing the pretty good bearing, but in many cases doesn't have a bearing at all. So you see it collapse like that quite a bit. So that is some of the things they don't quite right. And there's but it's a very flexible structure. You see a lot of crack sections, which I like. It's a very stable cracks, just have the cracks, just that they independently works like this. I don't see any problems with it, just be able to fix really quickly. It's a little bit stiffer condition like this. This is probably not good as the one vertical ones we see. I like vertical one because it has a lot of energy consumption going on. So one thing we noticed that basic material is good material, good clay they have. And if they built correctly, this can perform really well because we saw many structures is performed very well. Obviously, this particular archetype been developed millenniums, right? Thousands of years, people living here, and that's the only thing they have. And it's going through the earthquakes for thousands of years. So therefore, the construction, if it's done right, if it's used the right technique, the forefather using it, this is a very resilient structure. So in our opinion, there's no need to bring in cement. There's no need to bring in rebar. There's nothing to bring anything like that. First of all, no one can afford to buy anything like that anyway. So solution here is something to be able to use the vernacular architecture like this one and make sure the best practice is extracted and widely disseminated to the population. So that's not only be able to address the current needs of shelter to repair quickly, but also it will impact the generations to come, how to essentially build brickway, which they already know how to do right? For example, roof, don't make too thick. Just once at the leak in it, remove it and put it back. Just don't no more than say 8-inch thick. I think things like that are really critical. Make sure rock foundation's there so water doesn't go into the clay. And thickness, some cases you see the doesn't have a good thickness. Thickness have to be usually is a 50 centimeter thick and 5 meter. So about a 10-to-1 ratio. That is actually something that they should follow that. And you can see the plastering to make sure that the water doesn't into that. That's actually very important. In many cases, we saw a lot of collapse in a clay brick structure, especially if there's no plastering over it. That is so dangerous. But one of the probably most important thing is the bearing. That you see that this wood beam, many cases you don't have the bearing like this. Some cases very small. So once this system started moving it, you can picture it will essentially lose that, no bearing come off like that. That's how many people died. Hundreds of people died there. And I talked to many people, and you can see that the wall is kind of standing in it. You can see crack at the bottom, showing that evidence of a rocking. But meantime, when rocks, the roof came off, buried many people. Just that's the things like that. So having the small minor changes, well, not even changes, to use the best practice and inform the knowledge base of it. And that makes a big differences. So this is at the September 4th. This is the last time I was there. We have a team though. We have both a local and an international team working with the IOM and others to do this work right now. There's about 14,000 families are affected, their needs. So such as tents and all the stuff, there's a plenty of it, 40,000 supplied, right? And almost, it's covered. So everybody has a tent. Huge amount of tents out there. But tents, it's not good enough for wintertime. And so doing that, the resilient shelters, essentially what we're talking about, to just repair this, repairable structures, which is going to affect almost half of the total stock. You can get down to, but unfortunately, there's a funding gap of about 6,000 families right now still. So it's not reached yet. Right now, there are 8,000 capacities. It should be around about almost, I would say probably 2,000 units or maybe 3,000 units repaired using these methodologies. One of the most important things that so-called key message we provided, we obviously worked very closely with the shelter cluster system in the UM. I think it's a very important one. So not only our organization or IOM doing things, they use this basically the main different partners in the cluster system. I think that's a very important coordination part of it. So have a singular message to the community about the so-called correct way to reconstruct and recover. So you can see some of this is a bad practice, by the way. This one of the UN agency actually come to this one community, destroyed about 1,000 units, just destroyed. Because they said that those clay buildings is not good. Need to have a modern structures, bring in the bulldozers, build some concrete structures. They said that's a progress. It's a disaster. I mean, it's problem of this approach is not only that the people cannot build this way ever again. It's like a one-time solution, right? Really expensive. And it's an environmental disaster by itself. I mean, this is a remote community. Try to bring in the equipment itself is just a huge effort of doing things like that, right? And also it destroyed like a social structure about it. You see, we talked about compound wall system, and the people live in a compound, the high walls. It's very private residence, right? That's how the social structure is. That's where the women can be free. This is a Muslim country, okay? And that's how the cultures are made up for thousands of years. Women can come out, but they're completely free, completely good inside of this compound wall. But this system is actually taking down, everything's down. There's some little concrete boxes. I think that's a crime. It's just ridiculous. I mean, this kind of things like this, I see all the time and make me disgust, quite frankly, you know? So anyway, but that's just a small part of it. Many of our UN agencies do the right approach. And this is so we actually self-funded about 15 different compounds. We have a nonprofit called Miyamoto Global Disaster Relief, and we raise money. And we want to basically show actually what best practice look like. So because, agencies sometimes move slow, right? So we picked the 15 different compounds and trained the local. What we did is this. We actually at the first estimate at what's the cost of the repair look like. Usually average about $10,000 because that's a pretty sizable compound. It's about 2,000 to 3,000 square meters out there. And we actually provide money in the trenches to the homeowners. And they basically select and hire the local masons, many cases family members. They bring materials. And we train the masons, train the family members. So those are family members in many cases, and they're trained by us. We monitor them, but that's managed by the homeowners because the money goes there. I think that's a really important. Money directly goes into it rather than the use of contractors, and especially a place like this. And that also money given to families. They try to smart as much as possible, obviously, right? So yes, money stay there because they hired their families, friends doing this essentially, and there's capacity for that. So the construction, one of those, I mean, there is a beautiful structure. I mean, this is you can see that it's a very stable, very thick wall, and it's fairly small compartmentalized. So it's that the actual room itself is very stable as long as the good bearing of the wood. Those walls can move around. It's not a problem, and long as the roof itself, so after I put the joist in, put some wood planks, then provide the plastic seating. This is something they do throughout. Then have one layer of a clay soil roofing. Look like that. It's pretty amazing, isn't it? It's really, I thought it's really cool to actually so this is not something that we didn't invent anything here. We didn't bring anything foreign materials or foreign knowledge, none of it. We just extracted it to what is the best practice already exists. Already people doing it. Some people say, I know exactly how to build. I don't understand why people don't follow that. That kind of statement you hear quite often. So now that this knowledge, so far we trained about 370 masons now in the whole affected area. And so that knowledge, which they have, become renewalized, and they were going to keep doing this. So yes, it's definitely be able to impact this particular villages, but the knowledge where people stay, I think that's a very important component of it. Has to be really fast recovery is critical, and the money to stay, because money is important because people have no jobs, nothing after that. This can just happen, right? At the same time, the knowledge stay intact, stay there for affect the future generations come. So that's how the Afghanistan thing's going on. We got a little more funding from a UN agency, so we're going to be throughout our team. Our teams are mainly composed of Afghanistan engineers and our contractors, by the way, and with a couple of internationals involved. But they're going to be keep fixing these houses for this coming year also. So Ukraine. So after Afghanistan, I spent quite a bit of time in Ukraine for the last about 3 months or so. And I mean, it's a very different. This is not natural cause, obviously, caused by the Putin and the Russian attack. And it's a pretty brutal things they go through there today. So I spent quite a bit of time in obviously Kiev and also the front line on Kharkiv, which is the occupied area, or was occupied area. It's liberated about 2 months ago to understand the needs and damages context of it. And also the north, where it's been also the almost occupied area, stuff like that. Estimated about 150,000 houses being damaged. But this is for the just the liberated area. And I think go beyond that, which is a hot Kherson, or go beyond, there's more there. And amount of housing destruction is just phenomenal. It's just unbelievable, right? It was estimated about $70 billion damage at this point. And I saw a lot of education facilities has been damaged, a lot of them. And a lot to do with both armed forces use the school as the certain base. And that's why the education facility become targets of it, both the universities and also the K through 12 schools. Remember, this is for June number. Right now, it's much higher, and it will be much higher down the road. So here's Ukraine. Ukraine is a border against the Russian Federation and Belarus and Poland and Romania in the south. And Kiev, which is if you can see that, it's in right here's Kiev. And so that area you can see that the orange is in the blue. That's where the so-called war affected area per se. That's a lot of effect going on. So we spent quite a bit of time in Kiev and up in the north here at Chernihiv and Kharkiv area. So that's what's going on. And our team is sort of going down this direction also. If you're in Kiev, you just don't recognize it's a war. It's just like pretty normal, actually, that things going on. You know, there's statues, there's cathedrals, cafe, look like a typical European town. But every so often you hear this siren and you go to the basement, you know. And in September, actually, Kiev was pretty left alone in a sense. But since that October, first week of October, it's completely different. We get attacked about at least a half dozen times per morning. And it does destroy the critical infrastructure. And in some cases, target the apartments. So people die. And one morning, you know, I woke up 8 o'clock and I hear this big noise. And I thought some kind of gas explosion. It's actually the one missile hit about 1 kilometer from I was in. So it's definitely the tough condition. But I must say that the people in Ukrainian is unbelievable, you know. I mean, they just keep going. They know they just keep going. Doesn't matter how many attacks, what's not. They decide to stay. They're going to decide to be free. They got nowhere to go. They are going to live. So business is open, restaurants open, everything's open. Long as the power is electricity there. They just, I must say, just pretty amazing people. And you can see like this. Some cases you can see that the big hole in apartments. This is the town of Irpin. That's actually occupied by the Russians for about a couple months or so. And what they do is they shoot you the artillery or tank shell just penetrate through the apartments like that. You see a lot of this, thousands of them like that. It just for some reason they decide to shoot those apartments. There's no military reasons, nothing. Just going to shoot them. And so you see that those buildings and just the people still have to live. You know, just people still live in those apartments. Sometimes extremely dangerous condition, by the way. This actually is no bad one. So it's definitely some huge safety issue does exist out there. There's one about schools like that. Typical schools, you can see something like this, 2-3 story buildings, and many are pretty old structures and destroyed. It's interesting about the damage caused by the blast by weaponry versus earthquake is damage is much more simple in a sense because it affects in this case, windows, just architectural components, which you can see. You see a lot of those, and even like a school here, it's personal damage. So if you go beyond this, damage is pretty limited to just window. So, and this area is not earthquake area. So actually, cut off the damaged area and reconstruction of it, which is definitely a feasible approach about that. So you don't see the damage, structural damage in other areas except the place where the blast actually happens. So that's a huge difference between earthquake damage and versus blast damage, actually. And you can see the big holes like this. This is caused by the area bomb, and just the just huge impact. And you can see sometimes holes deep as I saw one as deep as like a 5 meter deep. I mean, huge craters everywhere. And some reason the industrial facility is being hit a lot. So every village, every town you go, either huge facilities like this one, it's gone. And big shopping malls also. No one knows why those things get targeted, but those shopping malls, industrial facilities, schools, large apartments, those are big targets for them. But you can see many of the damage is actually, this looks bad as this is actually fairly fast to repair this, because you can see the damage is come from the external pressure. It's in many cases caused by the aerial bomb, just that they hit the street and that caused this. And damage limited to the windows, or finishes. So there's no, like, say, structural damage, anything like that. So some of the damage can be repaired fairly quickly, even like this one here. So we are targeting right now, programming with the UNOPS and also IOM to really look the apartment building like this one. I can actually repair this so-called partial damaged structure like this one, so you can bring back the people in, the residents back to the apartments, and also the people who still live there be able to live safely. So that's one of the, I think that's a very fast way to get the people back. I mean, Russians can, in a way that the Ukrainians say that, Russians can break as much as they want to break, but we go fix them. I mean, they are pretty amazing, I must say. I mean, one blast I was talking about, I heard in a hotel, and that caused a huge, gigantic hole in one of the main street. It was a Monday morning, by the way. By Tuesday morning, everything fixed. I mean, and cars go by like a normal, it's just the super fast fixing they do. And so as a critical infrastructure right now, as you know, the many of substations and grids get hit, but team is available just repairing it right next day, even as we're being hit. So you see a lot of fire damage like this one. Those are a little more costly to repair, but it's definitely that it can be done. Once come to this way, it's probably not. It's just the damage is so intense. This caused by the aerial bomb. And but challenge here would be demolition of it. Now, just September this year, Ukrainians first time actually banned the usage of asbestos in a construction material. That's something asbestos is, as you know, it's cancer and potential cancer causing elements. And like places like United States or Japan or many countries banned probably 1970s or even beforehand. But it's been used widely. So every single structures, every single houses, there's the asbestos involved. So challenge the demolition of this so-called very toxic, in a sense, hazardous material contained apartments. How gonna demo it out? It's obviously that we can do anything what we try to do in the U.S. so-called envelope everything and stuff like that, abatement first. So there's about some certain approach about it. We've been working with the asbestos expert, see how actually use the moisturize first, and how to actually remove the elements. There's some certain ways I think that can be done to, it can be eliminate risk, but reduce the risk of the exposure. Many apartments fine too, though. You can see some windows blown out here and there. So people are living in a container like this. It's many cases provided by the neighboring countries like Poland, providing this conditions like that. But it's just cannot be lived like this forever. And plus, it's extremely cold in the hot, But they're sort of fixing it. There's a half-burned apartments on top, and local government does have capacities. It's not like they're waiting for someone to come rescue them. It's not like that. So they have a tax money for now, which can probably change that. But whatever they can fix, either in schools or even private apartments, they're fixing it. I was talking to this business, former business owner of this gentleman in Kharkiv area, which is at the east front line. And the area is occupied for almost 6 months, being liberated just recently. So he lost everything he had. No factories, nothing. He had, everything's gone. And but he had a little money, and he decided to sort of fix those apartments. And he was using the exact same strategy we thought would make sense, which means that if the 100, 150 units, maybe 10, 20 units will be burned. But if you fix 10 to 20 units, everything can be safe to be occupied again. So he's using his own money for public good. Public good, he's doing that. It's pretty amazing people, I must say. Here's one of the demolition going on. It's it's just pretty dangerous. It has no control. There's no watering, no moisturing in the area, just dust flying all over the places. There are no control at all. And we all know there are some certain asbestos components in this apartment like this one. Just you can see random shootings out there. And longer that the occupied territory, the brutalized is the worse. And either part of a tactic or just the way the Russian army behave, I don't know. But their method is just destroy, kill, much as possible. And that's something I saw that. But Ukrainians, keep coming back. I was talking to this lady in East Front Line. She just came back with the 2 kids. And she felt actually safer in the village now than major towns because you don't get missile hits anymore. And I asked her, why did you come back? Her answer was, well, it's my country. It's my town. It's where I live. So that's it, the people out there. Villages is something like this. Many destroyed. Those are usually made of a wood roof and a brick. You can see something like that. And so now, me and the global disaster relief I was talking about, we raised about $50,000 now. So we are fixing the 1 kindergarten, 4 houses like this one, and 1 apartments in the village. In a smaller the town or village, it would be the less international aids or less ables. There are many older people, babushka like this live. And so we go to a place like that. And and it's not rich country, that's for sure. Especially in a countryside, in the villages, and people that have no means to live without the business going. That's why people work every day. And even this lady is talking about windows, and she has no means to buy the window. So this is actually one of the houses we raise money to repair that. So you see it a little bit older folks and small kids living in it. So that's something you can see all the time. But those people are amazing. I mean, they lost half of a house, by the way. But this old 2 people, he was the contractor before, so he knows how to do it at least. So he started fixing it. It's pretty amazing, actually, I thought. And they have nothing. Sabine Cass, she's executive director of the Global Disaster Relief, and they gave us a borscht, this soup, they have. They have nothing. And they give us even bottle of jam, or if you go to a house, they give you a bucket of the apples, and it's just incredible. They have nothing, but they have to share. So I think those country houses, they need help. There's just no question about it, and they're lucky that the husband happened to be a former contractor, so he can do certain things. And, he's, by the way, that guy was 80 years old. He looked pretty robust, right? But many people don't like that. They definitely need help. So that'd be so nice. This is our country manager, Pablo. Great guy. He actually, when the war happens, he was in Germany. So he didn't go back then because he was outside with his wife and kids, one kid. And he came back to part of a reconstruction effort with us. And one day I was talking to Pablo about it. Pablo, are you going to go back to see your wife and the kids sometimes? You've been here for a couple months. He said, no. You understand it, kid. Once you come in, you're going to get out. I'm a male in a fighting age. I said, oh, really? I didn't know that. Yeah, that's how we go about it. We are committed. Ukrainians are committed to reconstruct their country. They're there to stay. Their commitment. It just is incredible people, I must say. And I'm really honored to associate with people like this, actually. So, yes, over the years, we worked in many, many disasters, and especially the earthquakes and hurricanes and the flood. But there's a conflict, especially active conflict area, and needs is very vivid, and it's just that they need help. Ukraine is not a poorest country. It's not like Afghanistan. It's not like that. That's true. But amount of damage, amount of destruction caused to those private-owned houses and apartments and schools, public schools, it's just horrendous, incredible. There's no way this country can do this, even how much commitments there. So here's the website of the Miyamoto Global Disaster Relief. If you go to the relief Ukraine components of it, and if you can donate even a little bit, even just a little bit, it adds up. It takes only $2,000 per family, even sometimes less, to have a huge impact to these people. That's about it. Thank you so much. Muchas gracias.
Thank you very much, Kit. It really was very touched by your presentation. It was amazing to hear all of that and sharing your experience with us. So now we're going to open the discussion, but before doing that, I just want to introduce our commentators. So we have here Dr. Miguel Estrada. He's a civil engineer from the National University of Engineering, Master of Science and PhD in Civil Engineering from the University of Tokyo, and postdoctorate at the University of Chiba in Japan. He has been Minister of Housing, Construction and Sanitation, Executive President of the CINICICO, General Director of CISMIT, Member of the Board Directors of CEDAPAL and FONAFE, as well as holding important position at UNIFIC. He teaches in a master's degree in transport and disaster risk management and undergraduate schools of civil engineer at National University of Engineering and Ricardo Palma University. He's president of the Peruvian Association of former JICA Peru scholarship holders and the recipient of the Order of Engineering of the Peruvian Engineers Association. I would like also to introduce Dr. Yolanda Alberto. She's a PhD in civil engineering, interested in soil dynamic, risk and resilience of critical infrastructure and networks. Assistant professor at the Department of Civil Engineering of the University of Chile, researcher at the Center of Integrated Disaster Risk Management, and director of the Project Risk of Losses in Drinking Water Networks of the Advanced Center for Water Technologies. She holds a degree in civil engineering from the University of Tokyo, master in engineering from the University of California, Berkeley, and civil engineering from the National Autonomous University of Mexico. Also, I would like to thank you very much, all participants. We have very participants from United Kingdom, China, Taiwan, Costa Rica, Brazil, Nicaragua, Peru. I hope that I didn't forget anyone. But yeah, so we have people from everywhere. And it's very exciting to see that. So shall we, I don't know whether from commenters there are any questions?
Thank you very much for the introduction, Dr. Viviana. First of all, I really would like to thank Mr. Kit Miyamoto, because it was a great presentation. It was very touching to see all the work that Miyamoto is doing around the world. And yeah, it was very interesting to see it from different perspectives, not only the technical part, which is, of course, something important when we are thinking about the infrastructure, but also from the societal aspect. And something that I really, that really stuck with me is the idea that when we are thinking about disaster risk reduction, we have to rescue this local knowledge. Sometimes, especially when we are thinking about these countries that have less resources, we usually tend to come with different solutions, or with solutions that they might not be able to afford or to keep. And this is something difficult for them to actually build resilience, because if they really want to continue with these solutions, they won't be able to do it with their own resources, with their local knowledge. And this will make it difficult for them to continue for a different disaster. And the idea that you are actually using this local knowledge, the local materials, and like something that is very important when we are thinking about the Sendai framework is that we have to innovate. And I think like innovation can come in different ways. Like we are thinking sometimes that we have to come up with different solutions and get rid of the local and antique knowledge. But actually, just thinking about like what went wrong, what were the mistakes, what were the critical parts of the structures that could go wrong and that could be repaired in a different way, but with the same local knowledge, same local materials. It's a part of that innovation. And I think that's really interesting. So I was thinking that, like how you came up with this solution, how you came up with this idea, and what are other ways that you are thinking of applying this for different disasters?
Well, thanks so much, Dr. Yolanta. I think this is something we see this all the time, you know. I mean, I was living in Haiti after 2010 earthquake for about 4 years then, you know, that earthquake killed about 300,000 people and destroyed about 200,000 buildings up there. So it was a huge effort. And that time, we noticed a lot of things out there that you're right about that. Somehow when, like, say, you know, engineers show up, right? We just essentially say, oh, so many buildings collapse. Everything that I've done is wrong, not good. Has to do something new. Has to do something completely different. I remember once that this President Clinton, he had this whole expo for this new housing type in Haiti, right? After the earthquake, there's about 30 types of incredible, imaginative future structures. Some is made of bubbles, some was made of bottles, some is made of all kinds of crazy things, you know. None of it, which I thought, you know, gonna stick to this country. I mean, how the Haitians gonna build this concrete bubble structure? I mean, just something may use in some different places, but not there. It's almost like a disrespectful to me, you know, no respect to the Haitians. You know, if you see that some of the ancient Haitian structures you see in jungles, it's incredible resilient structure. I know Dr. Andrea, she's here from Romania. She's talked about, that's her expertise, talked about quite a bit, and we collaborated with her. It's essentially it's a rock structure, but has this wood poles supporting this roof. And wood pole connection look like almost like a Japanese shrine. It's a Tonga group construction. So when the thing starts shaking, you just stay there. It has a fairly long period to kind of stay there. But all the rocks sheds when the earthquake hits, everything sheds. But nothing collapsed into the people's head, you know, because of this. Now that frequency change, right, from a fairly, you know, a high frequency to long, short frequency, just that shedding off the rocks, just having a pole structure. They can build back the rocks within probably 1 week. And when the hurricane comes, the roof made of that, you know, fairly lightweight thatch and stuff, that's gone. The rock structure is fine. So they build back the roof. You see how resilient this is, you know, and there's a need to change of that. Only changes we worked with locals, made the changes is that the poles, we put some horizontal guards elements in the inside face of the house, so the rock's gonna fall outward, not inward. That's the only one changes. I use the locally available stuff. I think that's that more like a cultural, anthropological kind of approach about it. I think that's something that the engineers, we got to understand that. It's not about engineering solution. It's about cultural solution. It's an anthropological solution. I think that if we have that, I think our solution will stick. It'll become it have a sustainable effort out there.
Yes, thank you very much. Yes. Dr. Estrella, yes, exactly. Yes, please, can you want to add something to that?
Sí, muy buenos días. Voy a hacerlo en español para hacerlo un poquito más rápido. Bueno, primero agradecer al profesor, al doctor Miyamoto, por esta excelente presentación y sobre todo que nos da la oportunidad de conocer experiencias, no solamente debido a desastres de origen natural, sino también desastres de tipo antrópico. Doctor Miyamoto, acá en Perú tenemos 3 regiones bien diferenciadas. La costa y realmente en toda Latinoamérica, ¿no? La costa que más o menos, obviamente bordea todo el Océano Pacífico. Luego tenemos, por el proceso de subducción entre las placas, tenemos una cordillera muy importante en Perú, donde también hay actividad sísmica, y pasando la cordillera tenemos la zona de la selva, donde también hay procesos de sismo. Lo que he visto y que quiero resaltar de su presentación son 3 cosas. Primero, el respeto a la cultura local. Eso me parece muy importante en el sentido de hacer una reconstrucción conociendo cuáles son las características culturales de esos sistemas de edificación. Paso número 1. Número 2, otro aspecto que resalto mucho de esta presentación es el tiempo. El tiempo de respuesta para la reconstrucción es fundamental. Obviamente tenemos los procesos climáticos que pueden llegar, ¿no? O mucho calor o mucho frío. Entonces tenemos, como autoridades, tenemos pues la obligación de darle cobijo a las personas que han sido afectadas por cualquier evento natural que esté así, ¿no? No solamente sismo, sino también cualquier otro elemento. Y algo muy importante es la parte tecnológica. Había mencionado algo que me gustó mucho, que es reconstruir, pero reconstruir mejor. O sea, no llevar a los procesos, y también ya la doctora Alberto había mencionado, ¿no?, que usar tecnologías para que el proceso de reconstrucción nos lleve a tener edificaciones mucho más seguras. Pero algo complejo, doctor Miyamoto, es la parte económica. Definitivamente allí tenemos, y usted también lo ha mencionado, ¿no?, acerca de la parte económica. Entonces, eso me lleva a pensar de que los estados, los gobiernos deberían tener unos fondos de contingencia económicos bastante importantes para afrontar estos procesos de reconstrucción. Le comento, acá en Perú tenemos 70 o 75% de construcción informal. Quiere decir que las mismas familias construyen sus edificaciones de la manera como pueden y como quieren a veces, ¿no? Porque tampoco no hay fiscalización de parte de las municipalidades, y me parece que ese es un problema también que tenemos casi en toda Latinoamérica y en casi todo el mundo. Entonces ahí tenemos una gran población expuesta, ya que vive en edificaciones altamente vulnerables. Entonces, por ejemplo, a mí me parece que el estudio que usted hace, muy interesante, acerca de evaluación de vulnerabilidades, no se puede tal vez de alguna manera sistematizar para encontrar estos grandes, digamos, áreas de vulnerabilidad, y con los procesos de reforzamiento, pues, mejorar la resiliencia de estas ciudades. Muy bien, eso por la parte de, digamos, del sismo. Ahora, por la parte del daño antrópico, eso es muy lamentable lo que hemos escuchado. Una sociedad civil que no tiene absolutamente nada que ver con los procesos de enfrentamientos bélicos, que sin embargo pues están afectadas, ¿no? Lo que sí me preocupó fue un poco los procesos de cómo reconstruir en aquellos lugares donde hay asbesto, ¿no? Nosotros sabemos que el asbesto, cuando está en polvo, pues es cancerígeno. Entonces, los procesos de demolición y reconstrucción me parecen allí que deberían hacerse con mucho cuidado y con mucha tecnología. Entonces, para redondear la intervención y terminar, la primera parte, doctor Miyamoto, y de hecho yo estudié en Japón, estudié en la Universidad de Tokio, luego estudié en la Universidad de Chiba, y tengo muy buenos amigos en el Instituto Tecnológico de Tokio, donde veo que usted también ha estudiado, así que tal vez usted sea mi senpai. Muy bien, entonces en el primer aspecto era acerca de la parte económica, ¿no? Como alguna idea Sé que Miyamoto es más que todo tecnológico, ¿no? Pero tal vez alguna idea de toda la experiencia que he tenido de cómo solventar estos procesos de reconstrucción desde el punto de vista económico. Y para la segunda parte, ¿no? La reconstrucción y el manejo de materiales peligrosos. Esas serían mis dos consultas, por favor.
Yeah, thanks so much, Dr. Estrada. I mean, you had such a great point about the construction, especially the Latin America and the Caribbean countries, you know. Like it's built in a very similar way. It's something we see everywhere, essentially made of a kind of confined masonry structure, adobe structure, brick construction, you know, something that seems like the whole world is made of like that. But interesting part of it that, like, if you bring back an example of Haiti, it's a poorest nation in the whole like countries, no question, you know. But subtle changes, I think one can make to the habit of it, masons, I think makes a huge impact. For example, they built in a very typical confined masonry structure. It's a concrete masonry unit, no reinforcement, obviously some reinforcement in column and beam elements. But one thing we noticed that it's just providing that rather than make a spacing of this tie reinforcement to be obviously a little narrower than this much, and have it especially at the 135-degree hook on the tie, and have a good engagement at the top, you know, column beam. As you can see, that makes a huge difference in the risk factor. It's not perfect, but it just have a certain ductility and it provides a certain ductility to it. And so we test some of those things, and it's definitely, you can see the huge difference in the two structures, and it makes the very subtle changes. It doesn't affect any cost components of it. It's more like habit of how masons do. So back in 2010 through 15, our company alone trained about 7,000 masons, and obviously there's dozens of other people trained like that. So it must have affected tens of thousands of masons in Port-au-Prince area. And today, so it was incredible. We back to 2021 earthquake and assisted some of the constructions made after 2010 earthquake. In a remote area, even like little school in a very, very remote area, they use this 135-degree hook. They use this guideline developed by the Ministry of Transportation and Public Works in Haiti now. And I ask those questions. How would you know those things? Did I teach you any chance? They said, no, I have no idea who the heck you are. I just learned from this trade school just around the corner. It became essentially the habit, become the knowledge about the so-called standard of practice of masons. Uneducated masons completely changed that after that disaster. So it's just that the capacity building of mass scale like that has just incredible profound impact, you know, and finance components of it. So I think that's a really difficult one because as you saw in Afghanistan example, a lot of money is spent on something completely wasteful, in my opinion. This concrete boxes is destroy the whole cultural context of a village here, right? And it's very expensive. And there's no lasting anything there at all, whatever, nothing. Destroy the culture, destroy the social context, destroy the architecture, just disastrous in my opinion. So that's expensive. But the approach that we worked with the cluster system bringer is very cost effective. It's anyone can build, you know. So we try to bring in the so-called funding into this type of things. So much more like obviously every disaster has certain funding, but there's a limited, right? So how can you use a limited funding into the most effective way? Many cases end up to like a capacity building and training, because as you know, after disaster happens, public money can only reconstruct somewhere average between the 10 to 15%. Rest of it, people have to build their own money. So what's the best way to do that is to build capacity of people, you know? I think that's important. And secondly, that whatever limited amount of money coming to the country should stay there much as possible. So should not have people flying all over the places to do stuff. You just engage the local engineering capacity, local construction capacity, local available people, materials, especially at the affected area where the money stays. I think that's very important. that makes a huge difference in the trajectory of the how recovery process, how fast, as you said, can go. I completely agree. Just no question. So that's a finance component of it. And second comments about the conflict area, about the. I'm sorry, Dr. Estrada, I lost myself. What was the second comments in the conflict area? Oh, asbestos, yeah, that's right.
El manejo de materiales peligrosos.
Oh, man. It'll be a difficult one because they're everywhere. I mean, the first, I was there in end of September and early October. I was kind of scared about this, just going to places because just you can see this fiber everywhere, After a while, I just got used to it, I mean, what else I can do? It's not like I can wear the hazard outfit and mask everywhere to go in, villages. It's not possible. So it's definitely I think you can't eliminate the risk, though. But we're talking to the Dr. Takahashi in Japan. He's specialized in the hazardous material in the construction site. And working with him to come up some sort of a simple guideline about the how to just reduce essentially if those asbestos fibers go into the air that become hazardous, how to contain it and how to actually depose that, So that type of something simple thing, something that the villages can do them on. I think that'd be very important. So that's something that we've been working on there right now with him and also with the UN agency. They got cluster, shelter cluster specifically for discussing this particular issue there. Thank you so much. And I think, Dr. Estrada, you got to be my senpai. It cannot be the senpai.
Thank you. Thank you.
Actually, I understand that also Dr. Alberto studied in Japan. So
yeah, so did I.
So we study together, not together because actually she's much younger than me. So, but we are at the same university, at Tokyo University.
Yeah, we're.
So what a small world is this?
Yes. Yeah. It's true, in fact.
Okay, thank you very much.
Thank you.
Thank you. Dr. Alberto, maybe you want to add something? I saw you with your hand up.
Yeah, yes. Thank you very much. So I just wanted to ask our last question about something that I was thinking that it's really important when we think about post-disaster recovery, and that's like economic reactivation. So something that you mentioned and that I thought that it's really important is that instead of bringing these people who will work and start like somehow like doing the works that the locals could do and then like reactivate their economy, this is like something that could be like one of the tools to reactivate like their work and their lives in some way. So, but I was wondering, like, what is this equilibrium between, like, what is the point where we can say, like, okay, you take charge of your own recovery, or like take our resources and then we are going to help you for this, and then from this point you can take on. So I think that's a difficult point, and I would like to know your insight in this.
I think that Dr. Alberto, what you said is so critical. And one example in Afghanistan, this one large international NGO. They have access to 10,000 volunteers in a country of Afghanistan, by the way. So they rather hire give money or hire the masons in the local area. They brought in volunteers. It seems like a nice thing to do, right? To reconstruct the houses. But at the same time, it took jobs away from local people. That money to bring someone from here to there, rather than it's very expensive to bring people from here to there. Rather than or also feed them, shelter them, everything, right? Rather than spend money to train, hire local people to do the work. I think that's kind of a thing. I think sometimes so-called volunteering. I know that's come from the very good place, to somebody volunteer to go such a disaster area, do things like that. But balance has to understand that got the money, got to stay. That's just so critical, and that's going to make a huge impact on the recovery process and the capacity building, everything about it, So, but I think what locals can be really helpful is like the expertise components of it. I think Japan does a pretty good job on there. Tsunami happened, right? They don't bring in the large contractor from Tokyo to reconstruct this, harbor in remote Tohoku area in Japan. They didn't do that. They send the money, they send expertise, local government. That's a responsibility to basically hire, execute the thing so money can stay. Obviously Japan do get exposed to many disasters, a lot, every few years they have something crazy things happening there. So it's definitely, they do understand how important to really activate a local capacity, especially the private sector, part of it, that will make an impact.
Okay. Thank you very much. I actually have lots of questions, but it seems that we are running out of time. So I just want to thank you again for this presentation. And I just want to thank you also our commenters and with their question, very interesting. And pass to Dr. Makare for the conclusion and the final remarks.
Thank you very much, Viviana. Before close the session and say thanks to everybody, please, I know that Miguel have to leave the room, so we will take this minute to take a picture, a photo. So I would like to just to pose for the photograph. Just now, you tell me, Liz.
Todos miren al frente. 1, 2, 3.
It's okay?
One more. Ahí. Gracias.
Okay, thank you. Thank you very much. Indeed, we have to acknowledge the contribution of Dr. Miyamoto. It has been a brilliant presentation. Thank you very much, Viviana, for the conduction of the session. All our co-organizers, two institutions, Cardiff University and Miyamoto Corporation, and also to our commentators, Miguel Estrada, Yolanda Alberto, always helping us to achieve our commitment, that is to contribute to the advancement of the SDGs as from the engineering. So we will thank to all the participants, and we'll announce briefly our next meeting, and we hope to see you again, all of you. Thank you to everybody.
Thank you very much.
Thank you.
Bye.
Cheers. Bye.
Okay, bye-bye.
Bye-bye. Thank you.